Okay, we are recording.
Okay. So, Damian, first of all, thank you for inviting us and give us an opportunity to present our work. Before we start, I would like to send greetings from Barbara. Barbara, maybe she will join us later. She has really emergent situation, obligation that she should do now, but probably she will join us. She should take the last part from the presentation. If she is not here, I can take the presentation, so it's completely not a problem. So who we are, actually, I have an opportunity to work with Barbara. Barbara was my supervisor for my PhD studies, and this was how I moved to Slovenia and how I met her. I'm more mathematician, like doing all this like mathematics, like in machine learning. And then she introduced me to the food and nutrition community. She's also a computer scientist, but then she said like, we have a lot of projects which were related to food and nutrition data, and we want to bring natural language processing, machine learning, deep learning in cases with food and nutrition data. And then, to be honest with you, when I started doing this, I was like 100 kilos. I was a fat, like young boy. And then working with food and nutrition data, I lost like 26 kilograms. So it was like worth to do this in food and working with food and nutrition data. Then I have an opportunity to go to Stanford, and I have done my postdoc at Stanford, and I explore a lot of like biomedical relation and health data, because I said, okay, now I am familiar with food and nutrition, but now we are going like in the era when it is really important, this personalized nutrition, but also related to the genotype and phenotype information of a person. And then I have experience working with biomedical data, and then after my postdoc came back to Slovenia. So this group is actually led by Professor Barbara Koroušić Seljak. I hope that she will join us later. And actually we are working with Gorjan Popovski. He will present today. He's our PhD student, and also Gjorgjina Cenikj, and she's working on her master thesis. And all these topics are related to natural language processing and machine learning pipelines, working with food and nutrition data. And today we are going to present only two presentations, and these are more in the domain of like data normalization with different semantic resources, and also like name entity recognition, information extraction. We have a lot of work done on the top of this, what we can do after our data is annotated to bring like machine learning and deep learning models for predicting macronutrients, micronutrients, and then correlations between macronutrient with some like health outcomes. So this is from my side, from the introduction. Thanks again for inviting us. And first, I would like to invite Gorjan Popovski and Gjorgjina Cenikj. They will take the presentation about information extraction, or they will be more specific in the title. Gorjan and Gjorgjina, it's your turn. Thanks.
Thank you. Hi, I hope you hear me well. If so, then I would start sharing my screen. Okay, waiting room. So please let me know if you can see my full screen right now.
Yep, we can. It's good.
Perfect. So then let me begin. The topic of my presentation and my close colleague Gjorgjina's presentation as well is from rule-based towards more robust corpus-based named entity recognition methods. We are part of the, as Tome mentioned, we are part of the computer systems department at Jozef Stefan Institutes based in Ljubljana and Slovenia. The first thing I want to talk about today is about what's the general motivation of having these types of methods that are in the title. So on the slide, we can see the quote-unquote data knowledge pyramid, where we can see multiple levels in each category. In this case, the general point of these methods that we will have a brief overview today is that we are in the data part of this whole pyramid. This pyramid represents how we get data to wisdom. So each step we need to take to transition from one level to the level above it. So data is something that is raw. Data is something that is just found or collected in the real world. Information is what does this data actually hide? What's the latent information in this data? And then to further climb these steps in the ladder, we have to devise devise methods and have data in order to reach the pinnacle of the actual pyramid, which is basically wisdom. In this case, let's formally define information extraction and specifically named entity recognition. So information extraction is the broader term of the two, which basically encapsulates automatic or even semi-automatic way of extracting information from unstructured data. When I say unstructured data, I mean data as it comes, with no predefined schema or no predefined format in which it is found. So unstructured data is something like raw text. Text is found anywhere. It can be from any data source. It has varying natures, and it doesn't have any specific format to it. So that is unstructured data. Specifically, a subfield of information extraction is called named entity recognition, which is basically the process of identifying and then further classifying concepts within a specific domain or a field or a topic. This means that if we have unstructured data, or rather text, the point is to find all the entities, all the terms and concepts or whatever we want to extract from the text, identify them correctly and say this is or is not one of them. So that's the main point of named entity recognition. There are just multiple types of named entity recognition methods. They can be based on multiple levels of data or multiple, let's say, levels of involvement of a human expert or a subject, or rather a subject domain expert. In this case, we just the most common 4 types are dictionary-based, rule-based, corpus-based, and methods-based on active learning. As the title suggests, today we will be talking about rule-based systems or rule-based methods, and then Gjorgjina will take over and talk about corpus-based methods, of course, in the domain of food. The first method I would like to briefly present the flow of is Dr. NER, which is basically a rule-based named entity recognition method, evidence-based dietary recommendations. So if you look at the graph, the flow of the actual method, the first 2 key points that we should notice is the input and the output. So the input is the first node on the top left, which is just a plain text document where we have some text that somebody has written, some text that's professional or some subject matter expert has written for a specific cause, for a specific audience. No hard-defined format here. At the end, we see that we have a list of entities together with subject, predicate, and object labels. I won't go into too much detail into this graph, but I want to point out the key 3 steps, which are pre-processing of the raw text. That's the first whole diagram on the left. Then we have detection and determination of entity mentions, which in this case is based on computational linguistics and Boolean algebra to actually detect these entities. And then the selection of and extraction of the aforementioned entities. So what would this look like practically? If we run this on a specific text, the text document I mentioned at the beginning, Dr. NER outputs the following. We have the specific entity that is recognized, or rather in this case, the whole sentence that is recognized as relevant, containing some sort of dietary recommendation. And then it gives different subject, predicate, object outputs, and as well as quantities you can see in these columns. So for example, for the first one, we have which actions are performed, or what is the active part of the sentence, which foods are recommended or not recommended, the nutrient they contain, and the quantity. So with this, we can basically extract these recommendations and have all of these quantities, the target quote-unquote demographic, which foods are contained, or which foods are recommended or not recommended, and the actual action. So you can see that the action varies and the target group varies. So depending on what's contained in the text, the system, or rather Dr. NER, will recognize that. Of course, we have to have this methodology somehow. In this case, it's a typical true positive, false negative, and false positive evaluation, which means we have entities that are recognized correctly, and a subject matter expert then manually checks whether the extracted information or the extracted entities are correct or not. In this case, just a very brief overview, the true positive should be, or basically hits. False positive, false negatives are things that are purportedly positive but are in actuality negative, and vice versa. Hence, false positive and false negative. So with this, we can basically see that the true positive value are much higher than the other ones, which means that this methodology is performing well. Move on to the second method that I want to present about is Foodie, a rule-based food named entity recognition method. Again, we can see the flowchart slide. I won't go into details of each phase, but I want to point out again some key points of this methodology. As we can see again, the input is some text document or recipe description or text in this case. This is free from text that can be written by anybody. And at the end, we get the annotated food entities. In this case, we of course have some pre-processing. Then we have some part of speech or some linguistical information in this text, which we need to extract using specific computational linguistics tools. And then we continue with semantic annotation and actually recognizing which specific entities are found and presenting them as they should be. In this case, this method differs from the previous one, because in the previous one, as you might have noticed, it extracts the whole sentence and then specific subparts of that sentence. In this case, if we're interested in the sole food entities, in what is annotated as an entity, not as a whole sentence or a whole recommendation, the output will be the following. We have some text, which is the whole text you see on the slide. It's just a recipe taken from some online source. And we can see that for each entity, for each of these food entities that are found in this text, it has basically highlighted them. This is, of course, a simple visualization. In essence, it will be in some machine readable format that can be interpreted in any way. The advantage here is now we have a clear-cut definition between which entity is a food and which is not a food. This is a rule-based approach, which basically means it takes computational linguistics rules into it as well as some semantic rules, unlike Dr. NER, which is based on Boolean algebra. And in this case, even if some entity is not found or present as a concept in any sort of resource, since we have linguistical information, this will also be will have a high chance of catching it. So if it's a green bell pepper or a red bell pepper, that doesn't make any difference linguistically. So with this, we have a list now of what is present in the food, in the recipe, in the text, what foods are present in the actual text. And of course, we have to somehow evaluate this. We follow the same exact evaluation method as is done in Dr. NER, one small addition. We, of course, compute all the true positives or the hits, so how many entities a subject matter expert has correctly said that they are indeed what needs to be extracted, false negatives and false positives as in the previous example, and this interesting little category called partial, which basically means that we have caught some of the words, some of the tokens as they are called in each entity, but not all of them. So for example, in the previous example, if I just caught bell pepper, but not green bell pepper, that's a partial match because this conveys some information. And with this, we compute the relatively classical statistical measures for evaluating such methods. We can see that it performs well under these circumstances, and we have a very high F1 score. With this, I would finish my presentation and give the floor to my colleague, Gjorgjina.
Can everyone see my screen?
Yes.
Okay, so I will now go on into shortly presenting corpus-based approaches for named entity recognition. When applying these methods, we are generally involving supervised machine learning models, which are trained on annotated data. And in the past, hidden Markov models, maximum entropy Markov models, and conditional random fields have been used for this task. And considering the success of deep learning methods for natural language processing, long-term memory or LSTMs and bidirectional long-short memory has also been used for corpus-based named entity recognition. Some advantages of these models are that they are generally more robust than the rule-based approaches, and they don't depend on external resources. They also eliminate the need for manual rule generation. However, they do require a large amount of annotated data. However, when such data is unavailable, they can be combined with active learning, which means that the models are not learning only from the annotated data, but also involve a human expert for getting the annotations they need so they can iteratively improve. I will present two such approaches, which are trained on the food-based corpus. The food-based corpus contains recipes from the All Recipes website, which have been annotated by Foodie, which is the second rule-based method that Gorjan presented. However, Foodie can only generate a weak annotated corpus, which still needs to be checked by human experts, so that we make sure that the models we are training are being trained on correctly annotated data. So the corpus contains food entities and their corresponding Hansard food semantic stacks, and the golden standard, which contains recipes that have been by experts, contains 1,000 recipes from 5 different categories. So the first method I will present is called butter, which stands for bidirectional LSTM for food named entity recognition. And this is the first corpus-based food named entity recognition method based on conditional random fields and BLSTM. Here we treat the named entity recognition task as a classification problem, where the classes are the tags from the inside-outside beginning or IOB tagging scheme. So here is an example of what that looks like. So if we have the sentence, place the sun-dried tomatoes in the water, here obviously the entities are sun-dried tomatoes and water. And this will be annotated in such a way that sun-dried and water get a B tag since they represent the beginning of a food entity. Tomatoes would have an I tag since it is in a food entity, but it is not at the beginning of it. And all of the other words in the sentence get an O tag since they are not in a food entity. So the idea here would be that the model would learn intricate and complex language features so that it can learn when it gets a new unseen sentence, it can assign this text to each of the words, and in that way we can figure out what is a food entity and what is not. So in order to do this, we first need to generate a numerical representation of each of the words in the sentence, and we do this using 3 pre-trained word methods, glove, word2vec, and fasttext. What these do on a high level is generate a vectorized representation of words in such a way that words with similar meaning are mapped together in the vector space. And we also consider training our own embeddings for representing words, which is done in the lexical model. The models we use on butter are based on bidirectional long short-term memory and conditional random fields. So the basic idea behind using these specific models is that the BLSTM processes the input sequences in both directions, so from the left and from left to the right and from the right to the left. And this can capture the sequential dependencies between the input tokens, while the conditional random fields captures the dependencies between the labels. And the reasoning behind this is that when we use this IOB tagging scheme, it doesn't make sense, for example, an I tag to follow an O tag. So the model would also take this into account when assigning the labels for each word. We also investigate how enriching the word representations generated by the pre-trained word representation models can be enriched with character embeddings. And the reason behind this is that we would also like to into account prefix and postfix information from each word, so that we can better have more information about that word, so that we can determine if it's a food entity or not. We evaluate the models using average F1 macro scores, and here we can note that all of the models obtain average F1 macro score of at least 0.89, and the best models achieve an F1 macro score of 0.94. So apart from Butter, which uses context-free word representations, we also follow the recent advances in natural language processing, and see how fine-tuning of BERT models can be used for named entity recognition. So here we also worked on another method called FoodNer, which is also trained on the food-based corpus. And the difference between Butter and FoodNer is that apart from detecting food entities, FoodNer is also capable of classifying these food entities into food groups from the Hansard corpus and the Foodon and Snowmed ontologies. The initial results are pretty encouraging. So on the food detection task, which is just a binary decision of determining whether a word is in a food entity or not, the model achieves an averaged F1 macro score of 0.93 to 0.94, while on the multi-class classification tasks, where we need to determine the category of a food entity, it achieves an F1 macro score of 0.73 to 0.78. So to sum up, we have presented 4 named entity recognition methods, 2 of which were rule-based and 2 of which were corpus-based. Butter is the first corpus-based food named entity recognition method, while FoodNer is the second, which also supports a multi-class classification into food groups. That would be all from our side. We'll be happy to answer any questions.
Okay. Now, do you want Tome to continue with your next presentation, or should we schedule a little discussion time right now about this?
Yeah. Maybe we can go in a small discussion, and maybe only to add to this presentation, because actually the idea here is, because I know that this group is more like in food ontology, all this annotation, which is done like to different semantic resources that are developed for the food and nutrition domain. But actually, what was our idea? We said, okay, imagine now that you have, for example, food dietary record data, which is coming from some patients, and they're typing what they're eating. And in most cases, these are, or you have some recipes, and these are related to obesity, some other health diseases. And the idea was, can we recognize what is the food entity inside? And then we start say, okay, we should extract this information from some textual data, or even more, for example, I don't know, but each country has like dietary recommendation, and these dietary recommendations should be updated frequently. And I don't know what is the situation in the other countries, but for example, in Slovenia, for 10 or 20 years, these recommendations are not updated, and there is a lot of new information which is published in papers. So we should follow this information, and the idea was, can we extract this information from some textual data? And for this reason, we start working with these rule-based approaches first presented by Gorjan, because actually to train some more robust supervised machine learning methods, we are not able, we don't have annotated data, we don't have corpus to train such a model like. And first of all, we start working with these rule-based approaches, but then we realize that there are a lot of, for example, all of you are familiar with this, when the project actually stopped, you don't have money to run the project, and there is a lot of sustainability problems. And for example, a lot of resources which exist, we are talking especially for Hansard corpus, there was a really nice like semantic annotator which can provide some food groups, but actually after the project stopped, then it was not available. And our computational linguistic rules for foodie were developed based on this annotator. We use this like an additional resource, like like semantic information. And actually, we need to change foodie on a much higher level and going deeper. But what was really nice, because when we start this rule-based approach, when we develop this rule-based approach, Matthew, I saw your, yes, they are available on GitHub. They can be easily. Actually, Butter is available because Butter was already presented at IEEE Big Data Conference this year, not this year, December 2020. And also foodie is also available as conference paper and is available on GitHub. And what we want to say, we are not able, but when we train foodie, we're able to annotate the data. And once we have data, then we train these more robust corpus-based approaches, and now we are able to detect, like, this was the reason. So first, how to extract this information, like Gorjan said, when we are talking about this data science or whatever, we are talking about levels between data, information, and then we have like knowledge and wisdom. But now we are still on the level like data and information, and now this information, the collected information, should be normalized. It can be annotated with food-on or some other semantic resources, and then we can continue in the next presentation what we have done in this direction. I think there is one question for Gjorgjina. This is, Gjorgjina, the question is about the publication by Foodner. Actually, it's still not available. It's under review process, Foodner, but we believe that it will be available in 1 to 2 months. Like, but I will show you how you can play with this. The code is still not available until the publication is not done. But at the end of the other publication, we can show you how you can use these models, because these models are already implemented as web services in one tool that you can play with other, how to say, recipes or dietary records.
So I'm in casting about for applications of the technology. So you mentioned one is taking a look at what food people are eating versus what a national dietary recommendation has. And that sort of conveys to me a little bit of a control board or a report that can sort of say whether the population is moving as time goes by towards the recommendations or not. Is that the kind of an example of the kind of project you could see coming out of this?
And actually, what was our idea? From one side, we have, like, as you said, food consumption data. And from our side, we should have this data recommendation. And we are going like in this planning or whatever and working with recommender systems. Gjorgjina has a lot of experience doing like recommender systems, but from other like topics, not food and nutrition. But actually, to have such, to train a recommender system, first we should have a stable data. And this data should be like normalized with some semantic resource. It should be annotated with food-on or some other semantic resources. So we are still on this level data information, extract information, annotate. And then once we have like stable data, as you said, like we can go, like we can analyze like different, like even we can go in, if we have food consumption data, to talk about the trajectory of how of food behavior, because people are talking about, for example, health trajectory or this electronic health records trajectory. So even we can go in this dietary trajectory and to analyze the what is happening there.
I have one more question, which is you mentioned the distinction between the rule-based and the basically text context based systems, word proximity within a corpus, and the issue. I was wondering if Foodner was combining the two. Is that what you said? That software combines the two approaches?
No.
No. Okay.
Actually. Yeah, I don't know if you are familiar, but when we are talking about this name entity recognition for all domains, there was in 2019 and then 2020 is actually the BERT model. And this BERT model was posed by Google, and actually is how the Google search is working now when we are searching for some keywords. And the BERT model achieved state-of-the-art name entity recognition in all domains. But to train the corpus, you should have like annotated data, and no one has this. And now when we develop the food base, we fine-tune, because as Gjorgjina said at the beginning, this Butter approach is actually can recognize but only food and not food. But if we want to do some other application on the top of them, it's really important the food group or the semantic type, if this is a fruit, vegetable, or even going how to say, lower in the hierarchy, like even distinguish between different fruits. And the idea was, can we, when we extract this entity, can we also extract the food on unique identifier from the ontology? And this was what was done there.
Okay. So two areas. So just first to dwell a little bit, one of your examples was the Barbara, was the sun-dried tomatoes in water, sort of doing away with all the pronouns. And what you can get in a text proximity analysis of that text is that sun-dried in water or water in sun-dried tomatoes are are not giving you the relations of the two things. So it sounded like your other approach was actually able to break up the text a bit more into its linguistic roles. It seems to me it's that threshold of technology that's sort of holding us back from annotating text a bit better. But I'll have to read up on your studies a little bit more, because I couldn't quite catch which one addressed that particular problem of semantics in the sentence.
Okay. Maybe to answer here, like we completely agree with these relations, and maybe Gjorgjina wants to add something, but actually Gjorgjina, she's working on her master thesis, and the idea is like to extract all this relation, and not only relation between like foods, but also relation food, health, and all these like disease treatments, drugs, like building a large like knowledge graph with this relation. So this was the reason why we developed Butter. Like we need something which will be like more robust to extract food entities, because at the end, if we want to catch the relation, first we should be able to catch like the entities and then looking in the relations.
Okay, well, so that brings me to my pet topic, which is OboFoundry family of ontologies, and the fact that we're trying to encourage the relation ontology to stitch together all of the different ontologies. So how is OboFoundry looking in terms of a resource for the vocabulary?
If I understand correctly, the question is related to OboFoundry, right? The design. We are not working from semantic perspective. Like our idea is like I will explain later how we normalize them. We use only we don't use the relation still, but as you said, like on the top, when we extract all this relation, it will be nice, and for us it will be easy like to follow the OboFoundry design principles, because on this way it will be interoperable with the ontologies that already exist. So our idea is like if we create this relation, the relation can be organized in a graph. And if we want to talk about knowledge graph, on the top of this, like we can use the OboFoundry design principle as semantic schema. And because, like for example, foodon follows this design principle, we can easily, for example, if we extract them with foodner, which give us like a unique identity that is coming from foodon, we have also the semantic information there. So on top of this graph, we will have semantic layer level, which is coming actually from foodon, and not only foodon. If we can use all other ontologies that exist if there are some missing gaps, and also, for example, data provenance for us is really important, from where this information is coming, because we cannot believe on everyone what is nowadays on the internet. So we can follow this when we are building the knowledge graph.
Yeah, great. I look forward to that ability to text mine and understand the linguistics happening in the content, and at the same time go take a look at the ontology view of the relations between those recognized terms. So I like to hear that progress.
And maybe one more question. I saw that Gorjan also answered something here in the chat. Thank you, Gorjan. But actually there was one question. Most online recipes have an ingredient list representing all food entities, so it is possible to use the information to construct a huge corpus. Yes, this will be one way how this will be a way how to construct a corpus, William. The idea is like with simple like grep rules, like regular expression rules, we can find this. But actually, this will be corpus only to distinguish between food or not food. We still don't know if this will be because in the ingredient list we don't have the food on semantic tags. or we don't have some other semantic tags in these recipes. And our idea is we want to go beyond this, what is food or not food, and we want to understand what is, if we have X, if we have something else, because as I said, we want to, from data, have information, and on the top of this information, then to reuse this information, this annotated data, food consumption or diet recommendation in order to improve, for example, some allergies or something like the obesity, cardiovascular disease, and so on. So this is a nice idea. This can help for sure, like what you are suggesting us, but this will help us only to distinguish between food and not food. And in current situation, we have really nice models that have like 94% F1 or 94% accuracy. So we don't want to have 99, to be honest. We want to go in this multi-class. We want to distinguish like food on. We want to distinguish like, for example, imagine how many IDs you have for food entities in food on. So we want for each one to be able to detect it from the text.
Yeah. One other quick question. So Foodon doesn't have a great multilingual synonymy. Agravoc does for food items. Yeah. Where are you turning? First of all, are you trying to solve the multilingual problem, or are you sticking to English in this?
We worked on English. About normalization, we have some preliminary results, actually published papers related to Slovene language. So we don't train the model like on multilingual corpus, but actually we use the same methodology, but only separate on Slovenian and English corpus. But this is more for normalization, not the information extraction. I can explain later. And there is one question from Matthew. Matthew, nice to see you here. Hi. It's about what about finding chemical entities in food within the food science literature? Actually, this can be done. But as we said, like, what was the missing part? If you go in these natural language processing workshops, you can find a lot of workshops in the past 10 years which are related to chemical entities. So we have such name entity recognitions. We can go through the text and we can extract this. And as Damian said, like, it's important the relation. But to find the relation, and actually Gjorgjina is doing this. So this is like, we are not presenting today, but you should extract also the food entities. And when you extract the food entity, you should have some robust for food entity. You can extract the chemical and you can talk about the relations. And for sure, we are able to detect this. I don't know, Matthew, if you are familiar, but there is one group from Barabashi Lab from Boston, I think. I don't know. Barabashi is famous in network theory. They have a really nice project about these chemical entities and food, and they have really nice publication in scientific reports. But I think we believe that this publication is actually really nice, but the idea is that they have done manually this. So they have for garlic and basilica several papers, and they are doing manual annotation, and only one part of the pipeline is only automatic. And we don't want to do this. Even we don't have enough funding to pay people for manual annotation. And this is the reason why we want to provide some semi-automatic approaches. Yes, the relation between the chemical and foods are more difficult, but to find them first, we should find a way how to extract the foods, because we are still not able to extract them. Actually, we are developing butter, food there and everything. And then we can start to do this. Actually, Gjorgjina has some preliminary results, but they are still like not publicly available.
It seems
okay.
A challenge just to recognize chemical names in the literature systematically. Kebi, I was just checking out some of Robert Warren's work in beer components, constituents, and discovering that Kebi doesn't actually list a number of them by the name that the beer industry is familiar with. It sounds like, I don't know, Warren, if you can comment on that as a NER problem. Okay.
So my comment is that it's nice to refer to it as an NER problem, but it's hard to get the machine to get it right if the human beings can't get it right to begin with.
And
And
lack of consistency.
there's a lack of consistency. Jessica is probably one of the best to comment on the chemicals, but just on the hops today, there's commercial varieties, there's scientific varieties. The two don't match, and I'm not sure that they actually match one to one as much as N to N. And just trying to get two scientists to agree on the sub-variety seems to be more than complicated. So part of the problem is just we're trying to split hairs, and nobody's really ever done it because nobody's ever really tried to do it.
Right. So Tome and Barbara, I suppose this is one cautionary note about the plant varietals that although there's some pages like on Wikipedia that list tons of grape and apple varietals, there are no other knowledge bases that clearly spell them out. So
yeah, but I think that I completely agree with what was said here, but maybe just to explain that we are coming from this computer science side, and we know all these problems which are there. And for sure, always when we are working with this extraction, we are working on level when subject matter experts are involved at the end to check all these results. Because for example, if I cannot find, I'm not a person from food and nutrition, I don't understand food and nutrition science. From other side, for example, I don't know if this will be true, even if different varieties exist on internet, or domain subject or subject matter expert cannot have an agreement if this is true or not. And this is this is from food and nutrition community. This should be an effort. And I can show you in the next presentation actually why these semantic resources and ontologies you are developing are so important in further to analyze. And for example, we can see also some gaps what are missing, because when you are submitting the paper and then you are doing the analysis from machine learning part and you are talking we annotated the data using this and this semantic resource. For example, some people reviews from food and nutrition community will say, yes, but you should go one level deeper. You should distinguish between different chemical substitutes in the foods. Yes, we can do this, but there is no research which is provided by the subject matter experts. We cannot do this if this exists. So I think this opens combining this food and nutrition science and also artificial intelligence from other side, open new gaps that should be solved on by both of these communities, and even it leads to some interdisciplinary studies, which I think it's nice.
Mm-hmm. Okay.
Can I follow that up with a question? It's more complicated than the chat, so that I would turn my mic on.
Yeah.
So, and this kind of relates to Warren's question, but what we're seeing here, thanks to chefs and thanks to research chefs and the food science community, we're seeing the development of new foods all the time. And as an example, I'll just use beer as an example, since that was already an example. We see new styles of beer happening all the time. And those new styles of beer contain different kinds of ingredients and things like that. So we have new names for things popping up all the time, and of course there's no agreement on those new names because they're new, and maybe there's convergent evolution in different parts of the world in terms of a new style of beer or something like that. So it's difficult for a manually curated ontology to keep up with those things. So just as a sort of a global strategy, can we just have a conversation about what that would look like? What's the global strategy for keeping up with the innovation in the food system in terms of the combination of ontology, AI, what have you? Because I think that's something that we don't tend to talk about. And we're all working little parts, but it seems that there's some convergence of technology that's important here. The question for you, Tome. Okay,
yeah.
Never mind, Damien.
Okay, I can answer this question actually. I think, first of all, if you don't have some data which is annotated, even if something new exists, if you want to come on the market, probably you should follow some metadata that you should provide, because we cannot keep track on everything what appears every day. If this is a branded food, even we talk about now, but for example, you can see from our trainings, we are not looking in branded food names. Now we train only on ingredients like beer. For us, I know that from chemical perspective, the beer is different. But for example, if it is different, it can have in this ontology like different unique identifier, and then it will be linked to this food composition databases from where we can extract this information, combine this information. I don't know what is the best thing to do here, because we are always interested on the data and to analyze the data. I'm just joking, but actually, from my perspective, and not only for this food nutrition domain, but if something new appear, actually, we should find a way out what is the metadata the people should provide in order to put this on the market. I know that everything exists now, but to keep track of everything which appears all days, I think it's not possible to do.
So are you suggesting something like a Dublin core metadata standard for food?
Yeah, because actually why I'm talking about this, when I was at Stanford, actually it was really nice project which was going from the Semantic community, like Mark Munson. And the idea was like that it was more for standards which are done in the biomedical laboratories. So for example, if some new standard appears, if you want this standard to be published and everything, and from the journals, or I don't know, some scientific, or if you want to publish as a pattern, the idea is that you should like fill metadata in order to keep track of everything. I don't know what is the best. I don't have so much experience to talk about this. This is only my point of view, that maybe it's not true. You are like, you have more experience working with food and nutrition data. I'm just giving my opinion about it.
I like it. It's a good idea. Cool.
Okay.
The ontologist
if I can
labeling.
If I can jump in, Matthew, one reaction that I have to you is that there's a difference in between the food and then the marketing of the food.
Sure.
And often the marketing of the food gets everybody into trouble. And Jessica and I have this argument about beer quite often, in that there's a new style of beer, but there's one brewery in Nebraska that uses it. And it has nothing to do with the same string with a brewery from, say, Prince Edward Island. And I don't have a good answer for you besides, is there a citation that's somewhat authoritative that we can use to actually reference these things?
So it almost seems like there's, well, I like this idea of metadata standards for food. And maybe there needs to be a working group on that. And different foods would essentially, if you want to call something a beer, there's a metadata standard to call something a beer. If you want to call something wine, there's a metadata standard to say this is wine. We meet these things. Not a regulation, but a standard so that people can move data around. Do you think that would be helpful in your world, Warren?
That's roughly what we're trying to do with the beer ontology. In my world, the metadata is the data, which is the metadata to the data, because it always lives in the same box. And I know that I've had arguments with Chris about this one, but I think that if you can just define what you're talking about in terms of metadata and in terms of food, you're way ahead to everybody else. And for example, so Jess P just posted, but DFDA, Health Canada, everybody else has a very legal definition of what a food is.
Right.
And that's a fairly good thing to start with, because it's grounded into something that's legally enforceable.
Right. Yeah. So Jaspreet, thanks for that. That's nice, but not every food has a standard of identity. In fact, relatively few foods have standard of identity, and mostly those standards of identity come from the food industry that makes those foods to keep other people from claiming things are what they are not. I mean, the history of butter is sort of goes into that, what you can butter. Okay, sorry. I mean, I just wanted to chase that down. I like this idea of using that idea of standards of identity, but then chasing it down something akin to a Dublin core metadata standard. I think would be really, really interesting and valuable for this community to dovetail with things like the food on group, because those could be elements that were essentially modular elements inside of those kinds of standards. At least that's the initial vision that comes to my mind as we're sort of spitballing this.
The part of the ontology community is just trying to play catch up to see how terms are used right now and have definitions and hierarchies for food facets. And then this other part is actually the vanguard of the ontology movement, which is actually de facto creating standards to finally describe foods and emerging foods. So I see, Matthew, your point about different subdomains of food, each needing a better overall definition. Well, it sort of comes to the fore with sort of designation of origin foods in that particular nations have a much more claim on. Food on just barely touches on this. We mentioned the three kinds of designation of food origin that Wikipedia mentions, but have nothing more to say about it right now. Okay, any other comments from other folks? Tome, that I'm not misreading that those two presentations were the presentations you wanted to bring to us today, right? Is that right?
Actually, we have another one because 20 minutes, but I can show you, like I can have a short presentation about the other thing, but if you want, we can also continue another session. But these two are related. This was the extraction, and maybe now is coming the semantic notation part. But how you want it?
Okay, well, I think this is up to folks in the audience, because normally we book an hour, but we could stay longer for another presentation, but only if there are folks who want to catch it that would miss it if they have to leave in 4 minutes. So if anybody has to leave in 4 minutes and really would like to see it in the future, let me know.
Damien, what are you doing with the recordings of this? Do they go up online?
Yes, for the join in food. Yes, they can. So that's a good solution. Good point. All right. Well, let's roll with the next presentations then.
Okay. So to move on to next, yes?
Yep.
Okay. Just to find. Probably you can see the screen, right?
Yep.
Okay. Let me try to just. You can see this presentation, right?
Yes.
Okay. So what is the idea? As we talked before, we talk about, okay, how we can extract information from text, from unstructured data. And now we're going to talk about, and I will be short, like food semantic annotation across different semantic resources. So this presentation will be done by me, and it should be by Barbara, but Barbara cannot join us, I think, and she sent greetings to everyone. So now imagine that we extract this. We have the food concepts. We have sun-dried tomatoes. We have banana. We have egg. But how we can annotate it? How we can put like identifier from some semantic resources? And there exist different standards and systems that can be used for data normalization. For example, in Europe, there is a FoodX2, which is developed by European Food Safety Agency. Then we have the Langwell. We have the Foodon. And I think some parts from Foodon are also following the Langwell standard. Then we have OntoFood. And what is really important is the SNOMED City. Why? Because actually this is the most widely used ontology in the biomedical and the health domain. And for example, if you want to connect like further to investigate relation between like health and food concepts and nutrient concepts and chemical concepts, like SNOMED City has also chemical concepts inside, we should find a way how we can link, like how to make all these like ontologies, how to perform ontology alignment. But we are not doing this, and we are going to show what we are developing, like what kind of semantic resources. And we have this Hansard corpus, which is coming actually from, it's a corpus for annotated news, but also there are some food entities. So what we are doing in this, first we developed one method, which is actually if you want to have your data annotated with the FoodX2 system, and actually this system is also supported by World Health Organization and also FAO, Food and Agriculture Organization, because they developed like a food consumption tool. And if you want to upload your food consumption data, you can upload the data only if you have like FoodX2 codes. And this is a time-consuming task. And if you have like to annotate your data, you have a lot of time to spend, like 1 month to find the FoodX2 codes. So what is the idea? I'm going to talk about the 3 parts. First, you should classify your data. Do you have a raw ingredient, derivate, or you have some recipe? But what is the most important part for us is the description. And now imagine that you have like sun-dried tomatoes and you want to find the FoodX2 code. So you can go in the Excel document or in some database. You can manually search the data, then you can put the code. And if you want to repeat this for each ingredient, and you imagine that you have millions of food concepts, then it will take a lot of time. So what we are doing, based only on the name, the description of the name, we are actually looking in the database with a lookup search, and we are finding the most appropriate FoodX2 code or the most appropriate food concepts. And what we are doing here is actually from the food description, we are extracting nouns, verbs, and adjectives. And then we are looking in the candidates from the database, which only have the nouns. Why? Because nouns explain and carry the most of information, and verbs and adjective only explain the food concepts in a more specific form. For example, verbs are related to some cooking procedures or something else. And on this way, by matching like the similarity between the nouns, verbs, and adjectives finds into description, actually we can find if we have the same food concepts or not. Then actually we can retrieve from the database the FoodX2 code. How this looks actually, here's how the classifier works on the upper table. Actually, we can classify if we have raw ingredient, derivate, we have some simple recipe or complex recipe, and this is a standard which is actually from the FoodX2 system. But what is most interesting is the description part, which is actually in the table which is down. And for example, we have mushroom soup in our Slovenian database. And then using our approach on automatic way, we assign like A041R, and in the FoodX database, actually it's mushroom soup. And then we have the manual FoodX is the same. But what is more interesting, for example, we have prepared green salad, and we have this code which is actually resulted from our method. And how this concept is inside the FoodX2, it's the same, but it's only mixed green salad. And it's the same code which is done by the subject matter expert. And what is more interesting, for example, meat burger, we have meat burger, no sandwich, it is in the database. And if you want to do some simple matching, string similarity matching, you are not able to find all these matches. For example, what is interesting, you have brown soys, gravy, lioness soys. We are able to find the code from FoodX. And actually, what is the description in the database? In continental European brown cooked soy gravy. So if you want to find that this concept, which is in our database, it's the same with this, it's no chance to retrieve the real code until you check manually. So this is actually how you can find these FoodX2 codes related to your data. This was published in 2017. About the description, we have 79% of accuracy. But actually what we are missing, the missing part was because we have some Slovenian traditional foods. And as Matthew said, these foods are not presented in this FoodX2 database because they are so typical for the culture in Slovenia. So they don't exist there. So we are not able to find these codes. So this is also one interesting question. If we need to update this FoodX2 like standard from European Food Safety Authority, so how this can be updated in future. So actually this also opens new direction, like to see how these standards will be developed. And because in the previous method in Stanford, we were interested only in lexical similarity. Lexical similarity is actually looking for similar things between description, between text, only if we are using linguistics, like how the words are typed, like we are not caring about the semantic, the content inside. And for example, here in the upper table, we can see some food concepts. And for these food concepts to return like the most three similar food concepts that exist like in the database, like in the foodx2 database. And we can see, for example, for apples, we have apples and similar dry apples, and also we have apple strudel. And this apple strudel is completely different food group. It returns here because of apple, because we are doing only this linguistic lexical similarity, but actually apple is only an ingredient in this apple strudel, and it's completely different food group. And for this reason, actually, we developed this foodx2 back, and these are like representation for this concept. So each concept is represented as a vector of continuous number, and then we are able to find the most similar. And what was interesting, for example, for apples, we have like crab apples, we have TG codes, and probably someone of you is more familiar with this, but this is some Mexican apple. So these are in the same food group. So using semantic, using the content, even if the word is not typed like similar, there is like no, from lexical point of view, they have completely different forms, we are able to extract them. And actually this was published in a paper which was published in Food and Chemical Toxicology. But what was the most interesting part? Actually, when we developed Foodie to train the more robust corpus-based name entity recognition methods, actually we developed the food base. And the food base is published in Database, a journal from Oxford in 2019. And actually the idea is when we extract this information, like what we are talking about, we are extracting the entities, but not only we are extracting, we know where they are located in the text, but also we put the semantic annotation from Hansard corpus. And this was okay. Now, as I explained before, we use Foodie, we develop this corpus, and once we have the corpus, we can do like all these annotations, like training corpus-based entity recognition methods. And once we have food base, so we have these recipes, we have the food concepts where they're located in the text, and also we know the Hansard standard. And then we go to the NCBO annotator. The NCBO annotator, probably you are familiar, is a semantic annotator which is developed by a Stanford group, and it supports the bioportal. And for example, if you go on bioportal, you can find the food-on version, you can find OntoFoods, SNOMED City, mesh, all these like different ontologies that consist food concepts. So what we have done here, actually we took the same recipes, we extract with Foodie, we have the food base, which is a Hansard annotated corpus, but from other side, we use the NCB annotator for the same recipes, we extract the same concept with terms that exist in food-on, OntoFood, and SNOMED City, and all these other ontologies. So in this way, we created one resource which is actually food onto map. And what is the idea behind food on map? And I don't know if you are familiar with the biomedical domain, but the biomedical domain is based on one semantic standard, which is called Unified Medical Language System. And this standard is actually making relations and linking between different semantic resources that are used there. So the idea behind this is, for example, if I have some health concept in City, using this unified medical language system, I found the same code, for example, from some other ontology. And this is published in 2019, and actually it was also invited for extension. And before, I think 1 week, the revised version is published in a Springer chapter book. And what the idea? It looks something like this. It's a simple comma separator, similar to unified medical language system that exists in medical domain. Actually, we extract all these concepts, and we know what are the concepts, the tables, and we know the unique identifier. This can help, as I said before. Imagine that one group has food consumption data which is annotated with food on. The other group has food consumption data which is annotated with SNOMED City. And one is from Germany, the other is from United States. And if you want to compare this data, you are not able to compare this data because actually your data is described with different metadata. You use different semantic resources. So first you should normalize this data. You should bring it to the same standard. It can be food on, it can be SNOMED City on the other side. So what are you doing? Using this semantic resource, it will give you, for example, which unique identifier from food on is linked to which unique identifier in SNOMED City. And this is from all these like 1, 2, 3, 4, 5, 6, 7, 8 different semantic resources that exist. So after creating all this like food ontomap and food-based corpus, what actually we have done? We develop also Diet Hub. And what is Diet Hub? Diet Hub is actually, once we have these recipes which are annotated, we want on the top of the recipes, like not name entity recognition, looking like where these food concepts are in the text, but actually annotated the whole recipe on the top. So for example, why this can help us? We discussed before, for example, if we have recipes or we have digital dietary records, what people are consuming, what people are enjoying in food, actually we can use Diet Hub and to extract all these different ingredients on the top. So the idea is that we have all of this, but in our case, the annotation is multi-label. Because we use Hansard corpus and actually we know if it's X, then we have also the semantic tag for food. And if we have citrus fruit, we have fruit, and then we have fruit and vegetables. So we are able even to annotate it based on the hierarchy. Not only one semantic tag, but we are able to annotate the entire part, the whole path from the ontology or the whole path from this hierarchical structure, in our case, the Hansard corpus. So how this works is actually, we have the recipe. Once we have the recipe, we are getting all the ingredients which are mentioned in this recipe. And how this can help? Actually, we took different recipes with regard to the cooking style, different recipes with regard to the region, and different recipes with regard to the diet. For example, if we take with regard to the region, we look in the Italian, Mexican, Southern, Indian, Chinese, Thai, and Mediterranean cuisine. And because there are a lot of papers, and probably you are more familiar than us, that Mediterranean is one that has like recognized for healthy diet, is actually we compare if there's some statistical difference between the semantic tags which are used in the Mediterranean and the semantic tags in Italian, Mexican, Southern, Indian, and so on. So what we have done, we perform semantic annotation and we are able to extract the ingredients from the text. And once we extracted them, like we said, we have first data, we have information, and now can we have acknowledge? Actually, we use them to find if there is a difference between some different types of recipes. And I'm not going here in more details because we are limited in time. All of these, like what are the difference between the semantic tags in all these different cuisines, is actually presented in one paper from 2020, published in Trends and Food Science and Technologies. And further, we reuse the Diet Hub because actually it's an artificial intelligence method that can be used to annotate recipes. Actually, we used to annotate recipes which were publicly available before the quarantine and during the quarantine in the first wave of COVID-19 pandemic, which happens in March and April. And actually, we analyze what people are enjoying, and this is on a global level. So this kind of study can be repeated for all countries separately. If we hate, we can only run the artificial intelligence method. And what we are able to see, what are people increasing during the quarantine and what is decreasing during the quarantine. And actually, if you go on Food and Agriculture Organization of the website during the first wave of COVID-19 pandemic, actually you can see this in theory, like this discussion from food and nutrition experts, like the discussion in agriculture experts, what is happening and what they are expecting to happen during the COVID-19 pandemic, using the recipes on the top with semantic annotation pipeline. We were able to prove all these comments. And actually, this is available in one paper, which was also published in Trends and in Food Science and Technologies in 2020. COVID-19 pandemic changed the food consumption patterns. And at the end, just a little joke, we are always joking because during quarantine, people ate a lot of pancakes. So we are always saying at the end of this presentation, if you ate pancakes during the first lockdown, of the COVID-19 pandemic, you were not the only one, because the consumption of pancakes increases for 300% for the quarantine and during the quarantine. At the end, all these like name entity recognition methods and what we are talking about, all these different standards, like how you can find, for example, a food concept from a food on, how you can link to SNOMED City. actually we developed this FoodWiz application. It is published. It is available. Like you can find the paper. You can also find like a you can find a website where you can play there. Actually, it consists a lot of recipes. You can go on the recipe and actually you have all extractions. You have all food concepts, and then you have all tags. You have the Hansard semantic tags. You have the food on semantic tags, which are associated with these entities. You have the SNOMED city, and for some of them, you have also on top food. If you click on these tags, for example, if you have garlic and then you go on SNOMED city, or you have, or for example, food on, actually it will go to the food on, and you have the definition, so everything is linked there, and you can have like information, more information about the source, like the semantic resource. And even more, like as we said, this FoodWiz actually can be used for automated recognition of food entities, making the annotated food entities understandable to subject matter experts, normalization with respect to semantic resources, like one example is food on. Also, all these examples, like one question was, can we use FoodNer? Where is FoodNer available? Actually, FoodNer is plugged into this FoodWiz. So there's like a FoodNer tab. You can go there, you can put your recipe, you can put your dietary recommendation or whatever you want, and then it will be able to recognize like the food on concepts or onto food concepts or SNOMED city concepts, and you should select the semantic resource, how you want to annotate your data. What is also the benefit, because we are talking about, we cannot do this 100% shares. As you said before, like what Gjorgjina said, is actually our food on is provide us like 78% accuracy, but where the 33% we are missing? We are always give an opportunity to the end users to correct our data, to correct the false positive, but also to correct the false negatives, to add the false negatives in our corpus, but also to remove the false positives. This is the web address. You can access there. You can try. You can play with the FoodWiz tool. Also, you can find a way. This is a reference how you can find like more about the tool. And this is one example. You are putting your free text here. I'm not going now on the website because we are limited on the time. I would like to show you a short demo, but actually this is how it looks like because we don't have time. You have like text prediction. You are putting your text there, and all like you have here like all different food concepts which are recognized, and also all these food concepts, because we selected the food on model, actually we have the food on semantic tags for all of these food concepts which are recognized. So you can play there about this. And even more, as I said, if you go like, for example, for annotation, there is always a possibility to go in our data to see, for example, the food concepts. In something of this is not a food concepts, you can delete it, subject matter expert. Or if something is missing, you can go here, for example, you can go on the text, you can mark the text, it will appear downstairs, and then you can select the food on semantic tag, the SNOMED city as subject matter expert. So you are performing manually annotation using the FoodWiz tool. And actually, this was the conclusion for this presentation. And as I said before, one, to extract the information. And in this presentation, actually, we present how we can use lexical and semantic similarity measures for food concepts. Then a semantic resource for normalizing food concepts across different semantic resources, like the food on Tome resource. Because now if I have data annotated with food on, I can easily transform the data with annotation from SNOMED city. I can easily transform the data with annotation from onto food. So, or whatever you want. And at the end, all these like different methods, it is about 5 years old, like research and small steps. But doing these small steps, we're going like even more further. Because once we have one research, we are a step ahead to build a new machine learning natural language processing method. So at the end, we have the web-based framework like FoodWiz that can be used, like actually it consists of everything like information extraction and also the semantic annotation approaches. So these are the credits, Gjorgjina, Gorjan, Gordana, me, and for sure Barbara, because if we were without her support, actually we were not able to do this. Thanks. You have here some projects we're part of, we are still part of. So all these projects are like national or European funded projects which are related to food. A lot of people who are also involved in this workshop. I saw a lot of familiar people. Duccio, I'd like to say hi also to you. And also I saw that Francesco is there. So we are part of the FNS Cloud project, and we are doing some together some semantic stuffs work there. Okay, thank you for your attention. And so if you have some question, if you want to continue with the discussion, we are here and we'll be happy to answer the question.
Yeah, it's great and wonderful work. I love the mapping, and I see all sorts of opportunities for Foodon to help improve the effort, and really have my eye on this Foodon SNOMED mapping. So I'll follow up with you about that, because a number of people have asked about that to me. Other people, I'm sure there's many interesting.
That was awesome, Tome. You and your group have been super busy. It's like super busy. That's really impressive.
Yeah. Thanks, Matthew.
We'll all give it a moment to to soak in the impact of all that information and effort. One thing I was wondering, SNOMED, for example, this is just a smaller technical question, but is SNOMED adding to their food terms frequently, or is that sort of constant?
From my perspective, I think no. What we have done when we this was the work which was performed by Gorjan in his master thesis. Actually, he used the NCBO annotator with all these different ontologies which are there. And there is also, we didn't mention today, but there is one paper when we compare all these ontologies with NCBO annotator on this corpus, and still Foodon has the most of the coverage from all food ontology. But after Foodon is the SNOMED city. I'm not familiar if they update this frequently, because in most cases they are more interested in this. SNOMED city is actually the semantic. It's one part from the UMLS, but actually it's the most commonly wide use in this in the health domain. And I think they are more focusing on these disease, drugs, treatments, and all these stuff. But because they have a lot of energy there, they also care about the food and such kind of things.
Yeah, I'm sort of interested in these in SNOMED as a sort of a past model of not so open curation, where they're taking on all sorts of domains, and ultimately that has its limits. So I was wondering if they might turn to a more of an Obo Foundry style approach of integrating separate domains vocabulary, but that might be just a pipe dream. Anyway, so Foodon does commit in the next year to mapping directly with a manual check to the SNOMED food categories. And we may be using your tool to do it if you're saying that you've got a good confidence of in one direction or the other of the mapping. Any other questions from folks?
Tome.
Yes.
You don't have your Superman shirt on right now, but it seems like you put in a super effort in the last 2 years. What's next for you? What are you going to do next? Conquer the world of food.
Yeah, to be honest with you, the people who are knowing me, currently I'm applying for an ERC starting grant, but it's not in the food, it's not in the biomedical domain, because I'm more theoretician and I would like to do math things. I would like to provide methods that can be used by people. Actually, I'm more interested in computer science methodology, like the math behind, and then to offer the people methods and then to perform some analysis. I'm doing all these things like food and nutrition and biomedical because it's interesting to me. Every time people ask me why I'm doing this, I said, okay, I can do my math. I'm happy when I'm doing my math. But at the end of the day, you should bring some impact to the society, right? I know that we are bringing with developing such methods that can be reused in some domains, But actually, I believe in this. Like, I believe that working with food and nutrition data, and especially now personalized nutrition, we can for sure help a lot of like we can contribute to the personalized medicine. So I'm always excited when I'm working on such real applications and bringing like, I don't know, methods that can help.
Cool.
On that note, I'll just send out, leave on the group list a very interesting presentation I just saw on the gut biome, which shows how much that influences the personalized nutrition impact. So I'll send that out, leave it in the discussion group documents. Anyway, thanks so much, Tome and Barbara and Gjorgjina. I hope I'm pronouncing that correctly. And your other people who I'm not sure if they're still on the call yet.
Gorjan?
Yes.
I'm here.
There you are. Okay. Thank you so much for participating and bringing this to us. Lots to think over and lots to plan around.
Yes, and maybe one thing more. Thank you everyone for coming. We're actually organizing the Artificial Intelligence and Food and Nutrition track, which is at Applied Machine Learning Days conference, which will happen on March 1st at EPFL in Lausanne. This year, they are planning to be like in person, but based on the situation, it will be a virtual one. So if someone is interested to provide like a presentation there, it's invited lecture, because I know this group is working on similar things, semantic annotation or something with food and nutrition data, or even more live personalized nutrition can contribute to this personalized medicine. And what is the idea, how we can collect data and how we can play with the data. Actually, you can email us. There is a lot of free spots till today, so we can find a way how you can present your thing there. And there are a lot of like free tickets to attend the conference and everything. And I think it's really nice conference. It's not like a machine learning conference like a theoretical one, but actually is like bringing the industry. And we are co-organizing this track for the 2nd year. And actually we are doing this together with Nestle. So everyone who wants to present something there, you're welcome to be involved, like invited speaker, or even more. We have a really nice like pitches for 3 minutes, like interesting ideas. I can send to this I can send to this group an email with call for pitches and everything. So please feel free to ping us if you want to present some work there. Even it can be some work which is in progress or some really nice idea that can be done. Thanks.
I'm happy to send out a notice to our group so I'll follow up with you and get the information on it.
Yeah, great.
Great. Okay. Thanks very much, folks. And we'll see you in a month. And then the process meeting might be every 2 weeks, but I think we'll start that up in a month. Okay.
Bye.
Thanks, everyone. Bye.
Thanks.